Hey guys, I'm Nick and welcome back to the new tutorial. This one is the last tutorial in this year. Next week on Thursday I will be streaming nearly all day. I will let you know in the Patreon a bit later what exact time, but it will be basically from my morning here in Latvia. It's Eastern European winter time, GMT +2 I think, till the evening, which will be around 4 or 5 p.m. my time. Anyhow, I will announce that on Patreon and will give you a link and exact date and hour. And I will be doing some stuff for my Patreon, like I wanna update my that cover art on top, and in the meantime we can discuss any of your questions. You can ask all the technical stuff, you can ask any other questions that bother you, or we can just chat about weather, whatever it is. I will be very glad to hear all of you guys. And then week before Christmas, I think we all wanna kind of wind down a bit. I think I also need a vacation to recharge my kind of workflow juices or creative juices, whatever you call that. But yeah, and next year, guys, next year will be freaking crazy. But yeah, it will be next year. For now, we are doing this animation, which is fairly easy setup that initially I wanted to do like using one technique, but then I remember I used this puppet track with a little twist in one of my client projects. So yeah, let's jump into Houdini and I'll show you how I did it. So dropping a geonode, of course, and then we will working with the sphere. This sphere should be, I think, yeah, it should be polygon mesh, but we should add a pretty a lot of these rows and columns. So I ended up doing like 32 and 59, and then I want to select this top portion, this one, and I want to delete it because it will mess with our UVs, so that's why, yeah, we actually don't need that. Deleting bounding regions, skipping bounding regions actually, and our sphere, and we're gonna go 0.5, and these we should make them smaller, so 0.2, 0.2, and 0.2, and we now just will delete this cap. Unfortunately, like in the moment when I'm recording this tutorial, my animation is still rendering on farm because I fucked up with Redshift settings, and that's why this might look a bit like it's compressed in time. I mean, it's a bit rough because in ideal situation you would add that little, you know, all the Christmas balls have this little thingy, and then the wire here that attaches to the Christmas tree. I don't have that. I think you should add that little cap here. But yeah, okay, let's delete the group one. And then I wanna, so we will need this ball and we will need another version of this ball. So after this one, I wanna drop the subdivide node as a separate, kind of separate chain, logical chain. And for this subdivide, I want subdivided 2 times, then UV project. And with this UV project, it's crucial to set this projection type, set it to polar, and you'll see that, yeah, it's getting stretched a bit here, but I don't think that is something something really bad here. And probably initializing to YZ plane. Yeah, I think this will work for us, especially for our texture that we will be using later. And just for now, that's basically it. So yeah, just drop a null and call it out sphere. All right, and the next one also starts with a subdivide, like our second logical chain, but here I want to subdivide it like 3 times, minimum 3 times, better 4 times actually. And then I want to add that same UV project. Basically you can copy that like this. Just don't forget to hit the initialize button again, and yeah, we have our UVs. And right now I want to drop attribute from map. By default it will copy the color data, and it's actually the thing that we want. But here I'm gonna go to the res folder and check this texture v2, which this texture is a free texture from, free pick, I think. I just modified it in Photoshop. This is yeah, it was the one stripe like this, and then I just copied that a few times. So that's basically it. And I made it black and white. So right now you probably already see what we will be doing. We will be attracting particles to these white parts. But best way to kind of separate them would be just deleting all the non-white parts. So drop the attribute wrangle, and yeah, cheers to Canada Dry. I always use this function called luminance instead of I was like CDR at CDR, because you cannot just use in the group, because we will be basically like grouping by the parameter, and I cannot say at CDR like less than 1. What the hell? I can? Yo. All right, that was unexpected. But I was always like, maybe I was doing it like that, and then it, come on, like spaces matter. All right, whatever. Then we don't need this attribute wrangle. Anyhow, just if you missed a few my previous tutorials, basically you can use this luminance function at CD, and it's basically a float value, and where the luminance, basically the brighter the color is, the bigger the value of our at lum will be. So basically if I write down here at lum, is the same thing that at CD are, like grabbing one channel. But yeah, oh, all right, but just for the test, right? So damn, this wasn't working when I was on like Houdini 18.5. Well, anyhow, we can bypass this attribute wrangle and just use the CDR, and I want to select nearly all of them. So yeah, like this. I think this will be cool. So yeah, and now we basically just delete the group 2. So drop the delete, select the group 2, entity should be points, and yeah, here we are. We deleted everything, and we left with only with the kind of this ethnic writing and the Merry Christmas in the middle. So with this one we will be adding our pyrosource spread, because what I want to do is I will basically have a bunch of particles floating around the sphere, and then I want to attract the particles that are burning right now. They will be attracted to their kind of final destination. And that will be, it won't be like, if I will be attracting all particles at the same time, it will be just like they sucked into that sphere. But what I want to do is kind of try to make the writing with the particles we attract. So definitely we will need to scatter some points. So after our delete, I want to scatter points, and here I want to aim to something like 500,000 points. Yeah. So this is where we have a really clear picture of that ornament. So let me drop a group, and this group will consist of few spheres. You know what? Before we will be dropping these spheres, what I want to do is maybe shift it a little bit, or all right, let's skip it. So yeah, just drop a few spheres. So we will add a merge to our group, and here I will be spawning my spheres. So this first sphere, maybe let's enable the keep in bounding regions, bounding objects, group type points, boom. So this sphere should be like 0.2 in scale, and we will drag it down. So yeah, it targets basically this area at the bottom. We want to do the same thing to our second sphere. Make it from the top, and basically we can, yeah, I think we can just copy these two, merge them again, and for this merge apply transform, and bring that transform to the merge, like our initial merge. And for this merge, I wanna rotate them 90 degrees by by X, I think. Yeah, cool. So yeah, this looks pretty good. Merry Christmas, Merry Christmas. All good. So what I want to do now is create the attribute, call it temperature, as we always do. So temperature, group 3, value should be 1. And now I want to drop attribute triangle, and this is very crucial. We will need to store point IDs. Attribute triangle, and let's write down that at ptid equals to ptnum. Basically, we are storing the ptnum into the separate attribute. And now we can drop the pyro source spread. And in this pyro source spread, I want it pretty rapid. Okay, so I want to go with cooling rate set to 0, rate at 5, search radius at 1, and max neighbors at 100. And diffusion rate noise, I want to make it around actually even less, 0.05, I think. And yeah, let me choose the temperature here so I can see how it goes, and let's simulate a few frames and see. So it's around 180 till it gets like covered with all the hot particles. So yeah, I'm not particularly bothered about this part because it will be on the other side and we don't see that actually. In my example, I added a slight rotation. So basically, yeah, just add a transform here and here for the rotation. For the sake of speed of this tutorial, I won't be adding that. In our case, I would just want to show you that trick with the pop attract and how to render this one. But yeah, essentially we have our particles, all the particles hot, and that means that these particles will have the snowflakes in their position on this shape. So now what I want to do is, of course, file cache it. So drop a file cache, make it explicit for the render farm if you want to render it on the farm. And here I wanna make it like to the 210, I think, because we will need that 1 second here. So make sure you add that little padding. So 210 frames should be cached out, and hit save to disk. And now we have our 210 frames of our file cache done. Looks pretty good to me. And now we will need a pop network. In this pop network, we will add some wind forces and we will add our collider. So let's just in the first place drop our static object and merge that into our output group of the pop solver. So like that. And for our static object, we will need to get our out sphere, which I assume we will need to make a bit smaller. Yeah, so let's add one transform here before our null out. Let's drop it here, and let's say we want a 0.997, just like a tiny bit smaller than it is. And then we see that our particles are actually on top of that sphere. All right, that's good. And now I wanna check how a few forces will look there, but before we do that, we want to go to the source first input, and we want to select all points. And for the burst, we want to set it to be $SF simulation frame less than 2. So it means that we will just spawn these particles once, and then we can maybe, yeah, nothing happens because there are no forces. So pop wind is what I want to add here. And also I want to add pop interact, I think. So let's remove the wind right now, and I want to show you how pop interact actually looks. So it will try to keep the same distance between these points here. So we'll just kind of like explode away. But yeah, I think we can go with just pop wind with an amplitude set to 0.3. And yeah, let's maybe simulate a few frames and check what do we have. It's still, I think, yeah, I think this will be good. Maybe we wanna displace them a bit more with pop attract with a negative value. So if we get the force to be -1, and let's simulate it now. Yeah, so now you can see it goes, it flies away. This is good. We don't want this puppet track to be active all the time, so let's go with $SF less than, for example, 5, and with the pop wind, amplitude 0.6, swirl size 0.5, I think, and turbulence at 5, I think. And let's just maybe add a pop drag also after our puppet track. So now let's check how it looks. Yeah, this looks pretty good. So this is something I wanna see here. Yep, pretty good. So I want to simulate quite a few frames here, and then we will just kind of file cache that one frame, and on that one frame we will add time shift, so we kind of are always on that frame. So I think frame 120, yeah, I think this will work. So let's turn off the visualization of the temperature. So in this popnet, file cache after that popnet, and in the file cache we just want this one frame, so single frame, and file path explicit, save to disk. And after this file cache we want to drop our time shift node, and yeah, let's drop it after the file cache. And for this time shift here in the frame you want to select the delete channels and now hit the 120. So now with this time shift, we cached 121, so we're gonna go with 121. So basically now we are always at the frame 121 in this logical chain. So now if I plug another pop network here, for example, let's see what we will have. So I want to again emit the points once in the first frame. So all points burst set to SF less than 2. This guide, we can uncheck that, and right now you can see that we don't have any forces, but somehow these particles are still moving. So I'm wondering why it is like that, because we have the velocity attribute from the previous simulation. So what we want to do is attribute delete, and here I want to delete the v attribute, so our velocity attribute. So now if I play it, you can see nothing happens because we don't have any velocity and we don't have any forces. So then I want to adjust my p-scale, so drop the attribute wrangle and write down p-scale equals 0.001. This is for better pop collision detect microsolver work. Let's go inside of our second pop network, and here where all the magic will happen. So basically what we want to do is drop static object again, and again we drop the merge, and now we have the subpass, so our out sphere goes here. If your sphere is rotating, you want to select use object transform or use deforming geometry, something from these two. But for now, just merge the static with the pop solver. And here are a few things I want to do. All right, so first thing that we will need is sub solver, because we want to access the high temperature points here. So let's go inside of the sub solver, and here I want to object merge our pyro solver. So where it is, our pyro, definitely would be better if I just added a null there, but yeah. So copy, attribute copy from our object merge to the dop geometry, and here we want to match by attribute, which is our PTID, which this all time it is in our attributes. Attribute name should be temperature. So now I want to attribute remap, and I want to just add some sort of mask, temperature original name, mask is new name, and input max for the temperature will be 5 and out max will be 1. Then we want to add color, and now we can add ramp from attribute, and this attribute should be should be mask. All right, and now if we play, I want to check what we will see, and we don't see nothing. Well, oh yeah, of course, because we have nothing connected here. So the subsolver goes to the pre-solve, and yeah, right now here you will see, so these parts getting the temperature from our pyro solver. And now I wanna add pop attract, just so you can see. This pop attract, we will work a bit with this one. So what I want to do here is set the attraction type to points. This is very crucial. So let's go back one step, and I just want to add this null here. So null out texture, no, out points, for example. And yep, that's the correct one. So let's go back to the pop network, and here in the pop attract, we want to select the out points and match method. And this is very crucial. So we want a point per particle. And the thing is, at this point where we have our scatter, do we have our attribute? No, our PTID. No, we don't. And that's why I think we will need to add this after our scatter, and then this goes into out points. So we have the PTID here, and we have PTID here. So we can go into the popnet, and here we wanna, in the pop attract, we wanna select PTID for both our particle ID and our goal ID. And this means that every particle will be attracted to every point on our geometry. So this all is good, but right now, if I will play it, you will see that all of these particles will be kind of attracted. Let me just remove the color just for now. For the subsolver color, yep, no color for the subsolver, and you will see that all of them basically get attracted to that geometry, and it looks really cool. In this part, you will start to see how it forms. Pretty cool effect. Yeah, but one thing I want to add here is I want to work with the mask we have. So I want to click use expressions, and for my force, this force scale, actually no, I don't want the expressions here, I want an expression here. And for my force scale, I want to bind that to the mask. So force scale equals mask, and we have the mask here, right? Yes, we have. So right now you will see that only individual parts are getting sucked into that part, like to the geometry that we will be creating or revealing. I don't know, but yeah, basically it's hard to see right now because of these, but yeah, basically here you can see that. So of course right now it's looking pretty bad. Two things I want to add is pop wind and pop collision detect, and this pop collision detect should be here in this source first input chain, and collision target SOP, and it should be our out. It should not be our out points, guys. It should be this one where we have the geometry, because pop collision detect works with points and geometry, not points to points. So this one will be out, I don't know, Xmas geo, for example. Yeah, let's go back to the pop network. Pop collision detect stop pass should be out Xmas geo. Use deforming geometry, we can uncheck that because it's not deforming. Behavior group name, yeah, it should be, I don't know, hit PT, for example. For our attributes, we don't need any of these hit attributes, actually. Right. Preserve group, accumulate hits, I don't know. No, we don't need that. And response should be stick, and we are done basically. So right now you will see that the particles that hit our targets, they become red, and probably I will need to simulate a few frames here because it's not that fast, but basically as soon as that point hits the surface of the geometry of our Xmas geo, it sticks to that, and this is how we will be painting. You can see here all these particles, they are already on their position. So what we can do then is maybe add a bit of wind, I don't know, wind with activation till, I know, it's f less than 150, for example. Amplitude at 1, swirl size at 1.5, turbulence at 5, and I don't know, amplitude should be 0.4 actually. It shouldn't be that big. And the only thing I want to add here, which is also a kind of cool node, pop speed limit, because I don't want these particles to accelerate indefinitely till they hit the spot. They want to, you know, kind of the snowflake, it swirls in the wind and then it drops. So it's more like a smooth motion than rapid acceleration to the target. And maximum speed, I set it to be 0.4 here actually. And yeah, I think if I play it right now, it should look much more organic. Yeah, looks pretty good. The thing is, with this one, I don't want wind for the particles that are right now attracted. So for my pop wind, I want to use expression, and for this expression, I want to set the amp to be equal to the mask, but I want the mask to be one, like reversed. So 1 minus mask. So particles that, and I remember the first particles were somewhere here, so maybe they won't get the wind. It's hard to see right now, but yeah, essentially, basically, like all the particles that are right now heated, they won't get the wind. They will be just attracted. So yeah, and I think this looks pretty good. Yeah, looks good to me. So essentially that's your setup. You definitely want to file cache it. So let's drop the file cache after our pop network. And this one, yes, I wanna exact same 210 frames, explicit and save to disk. So here we have our particles swirling around, and you can see that they go fly away a bit, but then we kind of drag them back to our geometry. And this this looks pretty cool to me. We have some of them sticking out. Yeah, this look really organic, you know. If you don't want these particles to fly away that much, I would say we will need a bit more time to cache out, like simulate more frames, and then all of them will be nicely packed, kind of attached to our geo. But this looks more like a freaking storm, you know. I don't want that much particles. So what I can do is add a little mask that will influence the opacity of our particles. So after the file cache, I want to drop the attribute wrangle, and here are two things that I want to connect. So first is, of course, our file cache, and second one will be our out pyro source. And let's move this one here. This will be our pyro source. I want to get it into the second input. And or actually we can go not with pyro source, but just like our out points. It should be the second input of the wrangle. So out points, second input. Right. So I want to just measure the distance between two of them. So vector current pos is our P, and vector init pos is our position that we grab from the first input, which is our static points. So grab the P attribute from each of our points. And now let's create another attribute called distance, and let's use function distance to measure the distance between our init position and our current position. Cool. And we can bind to this with a color. So I know that distance I want to keep like between 0 and 2, and this goes here. Let's visualize it. Cool. So want to remap this color a bit. So definitely revert, and yeah, make it like this, something like this. Yeah, looks good to me. The only thing we forgot, and oh shit, that's a mistake. Yeah, that's a mistake, guys. I'm in a rush right now. So for this pop network, we don't need the fucking sphere. So object, only the pop object. And yeah, now it will work. Yeah, sorry, we will need to resimulate that again. But hopefully it's not that long. For me, it was really fast to simulate this. So save to disk again, this frame without the collider, without the sphere, and this pop opnet, we don't need all objects, we need just our pop object. And now it will work. Right. So simulating 210 frames again. So now let's check how it looks with a proper simulation. So you can see that we have much less particles flying around, and at 210 we have almost all of them where they need to be. So now we can drop the set root angle and the color, and we will need to adjust it slightly. So we definitely don't need all of these particles, but yeah, just let's keep it like this, I think. So it should not be like a snowstorm, in my opinion, in like how I was imagining that. But yeah, I think this looks pretty good, and we can optionally drop attributes blur and maybe blur our CD attribute. So attributes CD, nope, CD. Around 5 iterations will be good. Pin border points and checked connectivity set to proximity, influence type set to proximity, and yeah, this looks better. After that, I want to randomize the P scale. So attributes angle again, and also I want to randomize the orient. So orient equals rand at pt num, and then I want to randomize the p scale to be something around 0.01 randomized by point number, and I want it to be from something from 0.008 to 0.2 maybe. We will check when we will be rendering that. Now to these points, so here's the option. We can go with a trace node and create actual snowflakes, or we can go with tiny grids and then use alpha channel of our texture to make the snowflakes out of them. For me and for my not so powerful MacBook, I went with the second option, and I went without instances, because somehow it's really hard for, I'm using this Apple Silicon version both for Houdini and the Redshift, so maybe it's something with that. But yeah, I'm not using instances. So copy to points, you have this backend instance option, so I'm not using that. Maybe you want to check this backend instance and see maybe it works better for you. But for my grid, it's very simple, size 1 and 1, orientation XY, rows 3 and 3, and then I drop this transform node, and of course, I will need to make them smaller because right now they will be definitely too big. So I want to set this uniform scale to be 0.1. And then I add normals. And then I also project UEs, UE project. So initialize to best plane. Boom. Let's save the project and visualize copy to points now. And yeah, I think it looks not so bad, but something is wrong, and that's an orientation. So I think I will need to rotate my grids 180. Yeah, this looks better. So some of them, no, I think minus 90 maybe. Oh, and we have the color, right? So if I drop the color and I want to see that in just plain white color. So grid, let's go back 180. Yeah, I think this looks better. Yeah, definitely better. Okay. So we don't need this color here. We just need trail to calculate velocity and use this velocity for our motion blur, because motion blur is really crucial here. So compute velocity after our compute copy to points. And now we just need two materials here and merge, of course. So let's drop the merge, and we will be merging this one and our trail. And yep, this will be good, I think. Yeah, we have everything here. All right, so we will need two materials here, and yeah, let's maybe set up lights, cameras, everything. I'm not sure if I will be doing lights right now. I might just copy that from my previous setup, because it was really tricky. It's basically a combination of different area lights, and yeah, I started using Redshift not so long ago, so I don't want to be responsible for teaching you incorrect techniques. So yeah, maybe we'll just copy the light setup. But yeah, anyhow, we will need material network. We need the camera. For this camera, I know that it will be 1080 by 1920, focal length 125. Yeah, and for the material network, I know that I want to do RS material and another material and Redshift material here. Surface. Actually, we will need three materials because we will have a backplate. Out color, surface. All good. And yeah, let's set my camera. Should be something around this, I think, like that. Let's check the transform values. So X translate 0, Y translate 0, and Z translate at 7 point something. And then let's go back to the geo. Let's drop RS, nope, material. Material goes here, and this one will be our first material network, redshift material 1, and here this one will be material 2. Okay, let's go back and add a grid. This grid we wanna rotate it because right now we don't see anything. I wanna rotate it 90 like this and translate back in the Z value by -3. Right now, if we visualize it, yep, looks pretty good. All right, and for the light setup, yeah, I think I will just copy paste that. So I'm using the combination of the light dome and some area lights. So let me just show you where they are. So this is my light setup, and I'm not proud about that. But yeah. This somehow it works for me, but I still don't think that it's the best way to light it up. I suggest you placing different area lights, checking how it looks, and it was pretty difficult to render out kind of these snow particles. Plus, we will have the sorta metallic texture for our sphere, so that it makes it a bit hard to render out properly. But yeah, let's I think, yeah, let's fire up the redshift render. So new pane tab type, redshift render view, save the project, remove the grid for now, and set the camera to camera 1 and hit render. All right, so here we have our tiny particles, you see, or grids, but those are not the snowflakes I wanna see. So let me just target one of these snowflakes here. Let's zoom in like that, and yeah, I think it will work. Maybe we can add new camera. No, I think it will work for just for demonstration purposes. Yeah, let's make it narrow, and let's work with our particles, with our actual snowflakes. So here are the few things that we will need to do. First of all, I don't want them to be grid shape. I want them to be actual snowflakes. So I have the texture, free texture from Google, just like an alpha map of the snowflakes. So RS texture, and file name should be snowflake, and this is inverted, so if I drop this to my overall emission color, it will be, yeah, probably we will need to rebuild the redshift, and it's not working. Let me, just for the convenience, copy this camera. I wanna get a new camera, and I wanna zoom in into one of these particles here. So camera 2, yeah, just zoom into something like this one. Yeah, this one looks good. And let's see why we don't have it. So this is our particle, one of them at least. The one thing I want to do is maybe I want to set the UVs smaller than they are. Oh, yeah, I see. For the copy to points, I remember, here are the attributes we are copying from our particles, and we don't want to copy the UV. And right now, if I did everything correct, so I added this, you will see now, yeah, it works. So not UV show, so shift 6 UV, and yeah, it works, right? So let's go back to my material network, and let's see what we have. So I want this to be reverted, so RS ramp and revert. Yeah, this looks good. Then what I want to do is make the texture a bit smaller, like the scale smaller, so the texture will be bigger. So let's go with 0.77, 0.77, and offset should be 0.176, 0.14. Yeah, this looks good to me. And this should be plugged to the opacity color. Yay, cool. Now we have our snowflakes. We can see that there's something around them. That's not good. We wanna get this slider all the way back to the white. So now we have clear snowflake here. Then I wanna add a little bump map, you know. So let's move these away a bit, and let's add max on noise. This max on noise will be wavy turbulence. Octave set to 10. And for the input, the source should be UV vertex attribute. And overall scale should be 0.3. And let's plug that into RS bump map. And this color goes into the texture input, and out goes to the overall bump input. And this looks much better. Bump map should not be 1, it should be like 0.1 maybe. Yeah, like this. For my material, I wanna set the roughness to be 0.1. Color should be white, of course. Reflection color white. For the refraction and transmission, I went with a 0.1. And you know, these are not looking like real snowflakes because they are so opaque, and we want to add a bit of translucency to them, but not this translucency, because it will ruin your render times. Just like, trust me. Maybe also the bump map should be a bit bigger. So let's go set the overall scale to 0.8. Yeah, like this. Okay. Also, you see, now we will see all of our particles, and that's not the thing that I want, especially talking about like all of these particles. Maybe at frame 132, you will see that we have a lot of particles that are like in this part of the frame, and it basically looks like a storm again. And that's because we are not reading any attributes from our geometry, because remember, we have all the particles that we want to show they are white, and all the black ones we want to hide them. So we want to add that to our opacity texture, because we cannot just use color, because then we won't have the snowflake shape, because right now we are using that color to determine the parts that we want to hide of our grid, the parts of the grid that we want to hide, and we will have the snowflake. So anyhow, let's drop the particle attribute lookup or point attribute, RS point attribute. The point attribute should be CD. It's all good here. Maybe I also wanna add a bit of to the P scale, but yeah, anyhow. So we cannot just plug them into the emission, into the opacity, sorry. We wanna use RS color layer, okay, like this. And just to better visualize these particles, let's maybe make this material of our ball like red, just for now. Yeah, and at frame 210, we will probably see if we need to add more particles, because right now, yeah, I don't think that we see them. Just, yeah, let's restart the render and check. Yeah, now I think we will definitely need to go with a bigger P scale for our particles, because right now I don't think that I can actually see them quite well. Maybe let's zoom in a bit, yeah, like this, and let's just for a quick test, let's go this P scale equals P scale multiplied by 2. So yeah, just want to see how it will look. This might be too much, so 1.2 for the P scale. Yep, like this. And yeah, I'm curious. Yeah, right now, yeah, look at that. So this is what we need. So let's zoom out a bit. And this is pretty hard to render, to be honest. So we will be focusing on one particular part here, which to me looks pretty good. But yeah, anyhow, we should maybe let's go back to the frame 120. Let's restart it, and I want to get rid of all these points that are flying somewhere here, and I don't think that we actually need them because we have our distance set. So this RS, I mean, like talking about these particles here, and yeah, we can go with RS point attribute, plug that into the layer 1 of the RS color layer, and base color will be our texture. And this one, we want to plug that into the overall opacity color. And then for this one, the blend mode should be multiply. And then we will have, hopefully, probably restarting the redshift. Yeah, so now we have only these particles right here. So it's really slow to render, but I want to assure you that when they render out, they will look much better than they are right now. I also kind of want to check the materials for for this kind of snowball, or the actual plastic / metallic ball. I want to use the preset plastic, where it was paper, plastic, yeah, plastic here. For my red color, I want to go with this red. For my roughness, I will control that with a noise. So it will be rs max on noise. Let's plug that into the diffuse roughness. And this noise should be displace turbulence with 3 octaves. Input should be UV vertex attribute. And for the output, I just want to set the brightness like 0.08, minus 0.08. All right. I think we need to restart the redshift again. And I think for now, let's just go back to the GO1 and let's just focus on that one. So redshift material 1. Okay, cool. Oh, and of course, it should not be the diffuse roughness. It should be reflection roughness. Yeah, cool, like this. And then I want to use another noise for the bump map, I think. So let's drop another max on noise. Let's add rs bump map and let's plug the bump map into the overall bump input and out color into the input of the bump map. This is too much. We definitely want to go with something very subtle like 0.001, 0.0001. Yeah, and for this noise, I want to set it to be FBM with 10 octaves, and let's just visualize it. Yeah, this is too much. Let's get the scale of the noise to 0.1, and let's set the bump map to 001. Yeah, like this. So this looks much better. And also, I want the Fresnel type to be metalness. All right. So for this Fresnel type, I will go with with the color and edge tint. So this one will be this bright red and metal edge tint will be this dark red. And then I want to add some, I don't know, do I need sheen? I know that I definitely need some coating, and this coating should be 1, like this, roughness at 0.3. And for the color, I want to go with this red that kind of goes into more like an orange, like this. Yeah. And for the IOR, I want to go with 155, like this. All right. And you know what? Bump map, I want it more subtle. So like this. And max on noise, decrease the contrast a bit. Yeah, like this. So this looks pretty good to me. And now if we go to the frame 210 and let's check our copy to points, by the way. I think there's something wrong with them. Like, I don't think that orientation is correct. I think that we should go with YZ or XY. No, ZX. Yeah, we should go with ZX, definitely. That's what we need. And it will look absolutely differently right now. So let's check. Yeah, so this is how it should actually look like. We don't forget about this grid. So let's stop the render, go to material network. So this grid, I want it to be rough and I want it to be like off gray, like this 7F. So let's go back to the scene view, go to our grid for the render, material network, redshift render 3. And yeah, let's go back and we see our snowflakes. Nope, those are not the snowflakes. Probably we have to re-unwrap our grid because right now it's in the wrong direction, in the wrong UV unwrap. So yep, so we needed to adjust this to ZX plane at UV project. I ended up simulating a bit more frames so it's better to see, but in the end I think if right now it won't crash, I think we will have a pretty interesting, this kind of snowball effect. Not a snowball, it's a Christmas tree ball, right? With just the snow. But don't judge it right now because obviously it will become brighter and brighter. With this one, you definitely wanna go with a bit of post effects. I mean, a bit more exposure and contrast for this one, and of course go with some bloom threshold. You can decrease that like this, add a bit of bokeh, and yeah, definitely play with the amount of particles, the scale of these individual snowflakes. I mean, if I zoom in here, you will see that we are kind of pretty close to the actual snowflakes that transmit some light, but also we definitely see the shape of that snow. So yeah, feel free to experiment with this one. I wanted to show you this technique with the pop attract, and this can be anything. You can do some snow writings on the window. You can, I don't know, do some material transforms with this particle attract effect, and maybe some bind to the pop collision detect. You can bind any attributes. So yeah, feel free to experiment, and I hope you guys like this tutorial, and I would love to see and hear everyone next week, next Thursday, on my live stream. I will put the details on Patreon page, so check that out too. See you next week. Bye.